this video, I'll show you how to solve the ALEKS problem called Understanding the Common Modes of Radioactive Decay. This problem has got 3 different examples of radioactive decay. It's got some missing information, asking us to fill in the missing information about each one. Just for a little bit of clarity here, the nuclide, this is referring to the reactant of the radioactive decay, and the daughter nuclide, that's referring to the product of the decay. And then there is some information in the middle about how the reactant gets to the product. So first, on this first one, I have a nuclide that is tungsten 180, and it's telling me that this is undergoing alpha emission. So that means that this tungsten 180 is emitting an alpha particle, which has a mass number of 4 and an atomic number of 2, and it's asking me to figure out what the other product is of this reaction. Keeping in mind that atomic number is always conserved in these, so that tells me that whatever my product is, it's going to have an atomic number of 72, because 72 plus 2 is 74. And also we have conservation of mass number as well, so that means I need to have over here a mass number of 176. 176 plus 4 is 180. How did I know that the alpha particle or the helium goes on the right-hand side and not on the left-hand side of the arrow? That comes from the word it's being emitted, so that means it's a product of the reaction. So what exactly is this daughter nuclide? To figure that out, we're going to focus on atomic number 72. That's what identifies these elements, and then we're just going to go click on the periodic table, focusing again on 72, not on 176, just on the 72. On the periodic table, we'll see that that element is HF. And we want to enter in both the atomic number and the mass number as well. For the second one, this one is giving us the product of the reaction, magnesium 26. And we're trying to figure out what the reactant is for this. It's telling us that this is undergoing electron capture. So that means that this guy over here is capturing an electron. Electrons have no mass number at all. They have 0 protons, 0 neutrons. And their atomic number in this case is considered to be -1. It's the opposite of a proton. So we got to focus on conservation of the mass number and conservation of the atomic number. That's going to give us a mass number of 26. 26 plus 0 is 26, and an atomic number of 12. 13 plus a -1 is 12. We need to figure out what this element is. Again, we're going to focus just on the 13, go to the periodic table, and figure out what element has an atomic number of 13. That is aluminum. And all of this information needs to be entered in. You can't just say aluminum, you have to have all those numbers with it. And then the last one is asking us, how do we go from SM147 to ND143? To do that, we want to look at what's changing in terms of the mass number, what's changing in terms of the atomic number. I'm going to write this stuff down here. We don't know if this is going to be something that we're adding to the product side or something that we're adding to the reactants side. But I can see that there is a difference of mass number of 4, which almost always means that we're dealing with an alpha particle. We also have a difference in the atomic number of 2, so that makes it even better. So if we did this equation would be balanced. 147, 143 plus 4 is 147, 62, 60 plus 2 is 62. So we are definitely getting an alpha particle out of this. We have to pay attention when you pull this drop-down menu open, there's going to be 2 options for alpha particles, alpha capture or alpha emission. I'm not 100% sure that it says capture. Alpha absorption, maybe, I don't know, but we can see that we are losing an alpha particle here, so that means that this is undergoing alpha emission.